But before I do example number 4, I want to talk about some things. Write this down. Oh, that's horrible. Hey, what does the inverse mean?
The opposite.
Kind of. Kind of means opposite, yes.
Isn't it like the positive opposite? So like if you have, like you make it positive, it's negative.
Yeah, but in math, inverse means a little something more. It means the opposite operation was the phrase that I was looking for. So in math, whenever we talk about this, I always want to think of, it's the opposite operation, but you undo what's done. So when we solve for x, like if we have an equation and we solve for x, we do a series of inverses to move those numbers to the other side of the equation or the variable. So an additive inverse would undo what's being done. So if I were to say x plus 3, all right, we have a tendency to focus in on the numbers. So plus 3 is a positive 3, but mathematically we're adding 3. So what would be the additive inverse of that? Oh, I stumped you guys with all the fancy formal stuff. It would be the opposite number of positive 3, which is what? Negative 3. But we want to think in terms of math. Where it's not positive 3, it's also adding 3. So what's the inverse operation of that? Subtracting 3. Yeah, so let's think about that. So these two are what we call additive inverses. Now, here's a fancy word, multiplicative inverse. Uh-oh, this is where it gets a little crazy. So if I say 3 times x, right, I'm multiplying x, whatever x is, I'm multiplying by 3. What is the multiplicative inverse? Yes?
3 over x. 3 divided by x.
3 divided by x. Yeah, so we could think of this in a couple of ways. I could say I'm dividing by 3, but let's focus on the 3. So if I say 3, what's the multiplicative inverse of 3? 1 over 3. Those are multiplicative inverses. Does that make sense?
Yep.
What's the fancy math word for that? Reciprocal. All right, so the multiplicative inverse, we sometimes say the reciprocal. Is it OL or AL?
AL.
It's AL. Okay, good. Now, I want to point out one other thing. With the multiplicative inverse, we have to be a little more formal. If I have, by the way, when I multiply 3 over 1 times 1 over 3, what's my answer? 1. What if I have negative 3 over 1? What's the reciprocal of that?
Negative 1. Negative.
Yeah, it would be, somewhere we got to have the negative, but it's negative 1 over 3. Now, do you see how it would be easy to get additive inverses where we have positive and negative charges and multiplicative inverses if we just memorize the rules, how we might get them confused? Right? So what happens when I multiply multiplicative inverses? What will the answer always be?
1.
1. Always 1. Okay? One other thing I want to talk to you guys about. About 85% of the SAT is based on these properties. So if we talk about the properties, we're almost done. We're going to do one more example, but I got to define some things formally for you guys before we do it. So closure, by definition, A plus B is a real number. Now, when Mr. Adams writes an R with a slash through it, that means real number, right? You guys know that?
Nope.
Oh, that's why you're here to learn. Now you do. That was free of charge.
Thank you.
You're welcome. All right, so A plus B is a real number. Now, we don't care what A is, we don't care what B is, but the sum of these two numbers is a real number. So closure means that A plus B is a real number, then A times B is also a real number. That kind of makes sense. Doesn't it? 3 plus 4 is 7. 3 times 4 is 12. 7 and 12 are real numbers, yes. Properties. Properties. Thank you. Is that right? All right. It's hard. Yeah. I did that on purpose to see if you were paying attention. Good job. Good to see you're paying attention. All right, let's do another property. You guys ready? My mind moves so much faster than my hands and my lips. Commutative. Commutative. I think that's with an A. Yep, sure is. Commutative. Well, that's pretty easy. A plus B is equal to B plus A. I want to point something out. All this stuff here we're going to talk about, this is going to be additive properties, and these are going to be multiplicative properties. Okay? So the commutative property is basically saying it doesn't matter what order. Order doesn't matter. 3 plus 4 is 7. 4 plus 3 is 7. Right? Is 3 times 4 12? So what's 4 times 3?
12.
How do I write that a little more formally? Could I say A times B is equal to B times A? Now, like I said, about 85% of the SAT is based on these properties of real numbers. There's a lot of questions like this that kids forget. You've been learning these since probably about the 5th or 6th grade, but you don't use them every day. At the beginning of the school year, we always talk about them. We always skip through them. You guys do the assignment, it's like no big deal. It's really important, though, in precalculus and algebra because we use these properties for everything. All right, so that's a commutative property. We have additive and multiplicative. Associative. If I have A plus B plus C, well, that's the same as A plus B plus C. Now here, order doesn't matter, but we're doing it a little different. Does it matter where I put the parentheses? Mathematically, no. They're equivalent. The left-hand side of the equal sign is the same as the right, but the way I calculate it's different, right? What do I do first? Parentheses, right? Please excuse my dear Aunt Sally. Parentheses P first, right? Okay. All right. So, how would I write that? I'll do the first part. Let's do A times B times C. What's the next part of that statement? A. Now what? BC, yeah, but where do I put the parentheses? That's kind of hard to say. Let me explain to you how to say that, okay? A times the quantity, BC. So whenever Mr. Adams says the quantity, I'm always going to say the quantity is referring to something in parentheses. Yes? Why not? Okay, good. You didn't have a question? All right, let's do the next one. Identity. Oh, there's some identity properties. The identity property A plus 0 equals A. Now, what do you think? Why do they call it the identity property? Raise your hand if you know. Yes.
Is anything plus 0 is the same thing?
Yeah, you end up with what you started with. So I started with A, I added 0 to it, I still have A. How would I write that for multiplication?
A times 1.
Yeah, so, yeah, exactly. But think about it. I'm going to do A times something has to equal A. Now, can you see how students might get that confused?
Yep.
But if you think of the term identity, you're going to end up with what you started with. One, you would add 0. The other, you would multiply by 1. Does that make sense?
Yep.
That's an important property. Inverse we just did, so I'm going to skip inverse. The last one is the distributive property. Everybody knows this one. A times B plus D. How does that work out? Yes.
It'd be both A times B and A times D, so it'd be AB plus AD.
Yeah, so this thing right here is simply going to be A times B, like that, right? Plus the sum of AD. That make sense? And you could work that backwards. Factoring is working that backwards, right? So another way, when we talk about factoring, this isn't in your textbook, but we'll talk about a lot. When we factor, we're really using the inverse or the distributive property backwards. So if I were to say A times B plus A times D, what do you see in both terms? A. So when I factor it out, guess what? Does that make sense?
Yeah.
Okay. Whew, that was a lot of stuff. All right. Finally, we're going to do example number 4, okay? All right, yes. So excited. So back to example number 4. Example number 4 wants us to talk about the properties. So we're going to name the properties. Figure out the props. If I say negative 2/3 times negative 3 over 2 equals 1. What is the formal definition of that property? Yes?
Multiplicative inverse.
Pretty good. I liked it. I thought. Yeah, it's a multiplicative inverse. Let's do another one. You guys ready? If I say 3 times 4 in parentheses times 5 equals 3 times 4 times 5. Actually, you know what? Let's change it up a bit. I'm feeling sassy. If I do this, uh-oh. What properties are we employing there? I know I just covered this with you guys. I'm doing this on purpose. Let's go back and see. Which one do you think it is? Yes?
Unitive associative properties.
Oh, yeah. Well, it's either one or the other. Maybe. I don't know. What do you guys think?
I'd say
I'll say associative.
All in favor of associative, raise your hand. Why are you guys thinking that? Parentheses, right?
Yeah.
Yeah, okay, cool. How many think it's commutative? How many read it out of the book and know that it's commutative? All right, good job. I appreciate your honesty. You got to be careful, right? Because the associative has parentheses, right? And the distributive property has parentheses, but that's not what we're talking about. The commutative is basically saying it doesn't matter what order we multiply things in. Now, in this particular problem, we did use parentheses to determine the order that we multiplied it. For example, this one, this is the order we multiply in, 3 times 4 times 5. Over here, we're going to say 4 times 3 times 5. Now, we are going to group them, but really that's a commutative property. So on the SAT, they'll say, well, is this commutative or associative? A lot of kids will see the parentheses and go, oh, I know that's associative. It's not the distributive property, which has parentheses, and you push something through. But because it has parentheses, it's the associative property. Well, you get that wrong. This is the commutative property. So this is commutative. I suppose one could... I forgot. Yeah, commutative. Commute, not
How much
commute.
is it?
Well, I'm teaching commutative. I'm teaching RCIA tonight, and we're going to talk about communion, so it's stuck in my mind. I typed the thing up earlier today. Yes?
For like a way to figure it out for like commutative or associative, couldn't you just say like in parentheses it's a 3 times 4 and then on the other side
Well,
there's
yeah. So well, let's do. I hear what you're saying, but
that
look.
is A, B, B, A.
Yeah. So what would be associative of this? Well,
3 times 4 equals 5 and it'd be
yeah, it would be 3 times 4 times 5. And that's what Mr. Adams wrote down. Even I thought of that way. Like out of habit. That's what, if you notice, I switched gears about midway through writing it down. Now this would be associative.
Yep.
Because we're changing the grouping, but the order of the numbers in the equations are the same. So this would be associative.